So we are done with our Thevenin's theorem as a method of solving our assignment number 4 problem. So we are now using our Norton's theorem. So the given original diagram, I draw it. So I neglect or I forgotten RL or to solve to have I1. This is our I1. Suppose this is our I1 and suppose this is our I2. So to make it easy to solve for I. So let us solve for I1. So I1 is can be solved using KVL. We have 24 minus I1 times 0.2 uh, is equal to 0. So I1 0.2 I1 is equal to positive 24. This is negative, so this is negative 0.2, divide both sides by negative 0.2, cancel out, so I1 is equal to 120 ampere. Then I2 is equal to 26 minus 0.3 I2 is equal to 0. So solve 0.3 negative 0.3 I2 is equal to 26. So divide both sides by negative 0.3, negative 0.3. So cancel out. So I2 is equal to 260 over 3 ampere. So we can now solve for our ISC. Is I1 plus I2. The sum of I1 and I2. So 120 plus 260 over 3 is equal to 620 over 3 ampere. So we have now our I I1, I2, and our ISC. So we can now redraw again the diagram into this one, into simpler one. So we can suppose that Rn is our RL. So we can now solve for Rn is equal to R1 plus R2 is equal to, so directly solve 100 0.2 plus 1 over 0.3 raised to negative 1. Since it is R1 plus R2, then we have 0.12 ohms for our Rn. So we can now simplify this one into this one using the given Rn. So IL is equal to ISC Rn over Rn plus RL is equal to 620 over 3, 0.12 plus 0.5, so it will result 40 ampere. This is our IL. So since we have our IL, we can now solve for VL is IL times RL. So 40 times 0.5 is equal to 20 ampere, or 20 volts I mean, since it is VL. So our PL IL squared times RL, 40 squared times 0.5 will have 800 watts. Then so we are done solving our IL and PL and VL. So we are now we're going to solve our IA. So solving for IA, redraw again, then including our I3. So since we have our I2 and our I1 and I3, so we can now solve for IA. So let us first solve ISC. Again, ISC to negative I2 plus I3. So 24 minus 0.5 I3. So this the what do you call this one? This equation is given, or we get that in this one, I1 I2. So we can now directly solve. So add two equation, my plus 0.5 I3 plus 0.3 I2 is equal to 0. So addition, this is addition, so it will result to negative. Then cancel this one since it is negative 0.5 and positive 0.5. So when we add that, it will become to 0. Then 0.3 I2 is equal to 0. So solve for I2 again. 2 0.3 divide both sides by 0.3. So I2 is again 20 over 3. This is our new I2. So we can now solve our ISC, which is equal to negative 20 over 3 plus 48. So 124 over 3 ampere. So this is our ICE. So redraw again. So we have now our ISC. So we can now solve for Rn. So I redraw again this diagram to make it easy in solving Rn. So Rn is can be solved Rb times Rl over Rb plus Rl. So simply substitute the given. So we have 0.3 times 0.5 over 0.3 plus 0.5, which has the result of 3 over 16 ohms. So since we have now our given Rn, Rn and ISC, so we can now solve for IA EC. So we can have IA can be solved by ISC times Rn over Rn plus RL. So directly substitute the given. So 124 over 3 is our ISC. Then times Rn is 3 over 16 over 3 over 16 plus 0.2. So we can directly solving into the calculator, we have 20 ampere. So this is our IA. Since we got our IA, we can have our PA, which is can be solved by IA squared times RA. So it will have 20 squared times 0.2 is equal to 80 watts. So let us now solve for PB. Solve for PB. Our last step in solving, applying Norton's theorem. So apply KCL. So IA is I equal to plus, this is plus IB IL. So IB is equal to negative IA plus IL. So can solve negative 20 plus 40 is 20 ampere. So this is our IB. Since we have our IB, we can now solve our PB. IB squared RB squared 120 watts. So that is all for the Norton's theorem.